Hope you are all able to hear me. Someone can answer if you are able to hear me. Uh, I request someone to unmute and say if you are able to hear me.
Yes, ma'am.
Okay, that's nice. So the recording also started. So good evening. I welcome you all for the week one live interactive session for the course Polymers, Concepts, Properties, Uses and Sustainability. This course is taken by Professor Abhijit Deshpande from IIT Madras. And the live interactive session will be handled by myself, Kritika. I am a PMRF scholar at IIT Madras. Okay, so good evening and welcome you all again. Uh, so, since being the first session, let's also start a brief introduction of each one of us. As I already told, I'm a PMRF PhD scholar from IIT Madras. So each one of you can give a brief intro of yourself, your name, from which place are you in, and then what are you doing. So someone can start. I request people to volunteer and speak because this is going to be an interactive session. This is a live interactive session. Okay, don't feel shy. Okay, about anything. The even when we are solving the problems, it is going to be more of an interaction only. So don't feel shy in answering also, whether it is right or wrong. End of the day, it's going to be a learning process. Okay, someone can start. Maybe Rajiv. Can you unmute and just give a brief intro of yourself? Hello.
Hello.
Yes, yes, Mr. Rajiv.
Yes, madam.
You can just give a brief introduction about yourself.
Madam,
Where are
myself Rajiv Arora.
yes.
Uh, I have worked in the engineering colleges, private engineering colleges.
Okay.
Presently, I have taken the leave for the one and half years.
Okay. Okay.
So presently at home.
Okay.
Before
Okay.
that, I am working as a principal in Krishna Institute of Polytechnic, Bijnor.
Okay. Okay. So okay. Okay. So which course you were teaching?
I am taking the basically the heat transfer, mass transfer, that type of subjects, and my specialization in polymer technology, BTech Chemical Engineering specialization polymer technology.
Okay, that's nice. Nice, sir. So next person. Thank you, sir. So next person. Uh, Prajwal.
Hi, ma'am.
Hello.
Thank you so much for conducting this session. As my name is Rajwal. Currently, I am working in a polymer compounding industry, and I done BSc in chemistry. After that, I done my PG diploma in polymer processing and testing from CPAT Lucknow.
Okay. Nice. Nice.
Uh,
Welcome.
yes, ma'am. And my work areas involve polymer testing and polymer processing from injection molding as well as extrusion process also.
Okay. Okay.
So,
Okay.
so I enroll two, three courses from NPTEL which are related to polymer. Uh,
Oh,
so, and it's my first course from NPTEL. So I am eager to learn and how can I use this opportunity to grow my career.
sure.
Yeah.
Sure. 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 Uh, so next person. Satish Babu. Sir, can you unmute and speak? Able to hear you properly.
Hello.
Hello.
Good evening, ma'am.
Good evening.
My name is Vishnu. Present, I am working lab technician VIT University, Andhra Pradesh. Um,
So, in which lab you're working, sir?
Physics lab.
Physics lab.
Physics.
So, okay,
Yes.
nice.
BTech
So,
student.
okay, that's nice. So, how
Uh,
come you are interested in polymers?
I will join PhD, ma'am. Part-time PhD. I will join
Okay,
polymers.
okay, that's nice. Nice. Okay,
So,
yes, sir.
thank you,
Thank you.
ma'am.
Uh,
Okay.
next, Sneha Kumari.
Good evening, ma'am.
Good evening.
Myself, Sneha Kumari, pursuing BTech in Chemical Engineering in Assam Engineering College, Guwahati.
Okay. So, which year you are in? Sneha, you are able to hear me?
Ma'am, third year.
Third year. Okay,
Yes,
nice.
ma'am.
Nice.
Fifth semester.
Nice. So I welcome you all for the course. So this course is going to be a very nice introductory course for polymers, covering various aspects. Okay. So few things I would like to say is that please go through the lecture. There has been lot of effort put by the faculty. Uh, uh, so please go through the lecture. You will get lot of information in the lectures. Okay. So please go through the lecture. I request Mr. Rajiv to mute himself so that we don't get the disturbance.
Yep, madam. One thing I am disturbing you. I have prepared a one nano composite material based on the conducting polymer.
Okay,
I
sir.
want to check some characterization of that. Can you help me in this matter?
Uh,
That is
I mean,
basic the nano titanium dioxide and the polyaluminum composite.
okay, sir. So what do you exactly want to do? Maybe we will discuss this at the end of the session.
Yes, madam. Okay.
Yes, sure. Uh,
Thank you, madam.
yes. So make use of the lectures very well. And also, if you have any doubts in the lecture, you can ask in these live interactive session. And also, there is a forum for the in the course, so you can type in your questions in the forum, and the questions will be answered by the faculty as well as myself. Okay, so please make use of the lectures and forum effectively, and also the live lectures. Sorry, the live interactive session. And one more request is that before the live interactive session, try to go through the lectures so that you're able to answer the questions. Uh, okay, but don't worry whether the answer is right or wrong. Okay, whether it is right or wrong. If it is going to be wrong, I'll help you in correcting it. Okay, it's end of the day, it's going to be a learning process, and I request you all to participate and actively answer the questions. Okay, don't hesitate yourself. Okay, from answering. Okay. Hope you all understood. So, did any of you go through the lectures of week one, and did anyone try attempting the week zero questions? Uh, Mr. Rajiv, you have raised your hands. You want to say anything?
Ma'am, yes, I have tried for that
Okay,
questions.
you tried answering the week zero assignment, is it?
Yes, ma'am.
Okay, you were able to answer the questions.
All the questions we have submitted all the assignments till now.
Oh, okay, that's nice. Okay, that's nice. Fine. So let's officially get on to the session. And also any questions related and all you can freely ask in the live session also. Okay. We'll try to help you out. If I'm not able to answer in that particular session, I'll note down your questions and I'll try to answer through the forum or in the next session for those questions. Okay. So please try to make use of the session as much as possible. Fine. Now let's get on. And if you are not able to, if your mic is having some problem or some connectivity issue, you can also type in the chat box so that I can read through. Okay. And when I'm in the presentation mode, please give me some answers. Okay. Because I may not be knowing whether I am connected or my internet connection got disconnected when I am in the presentation mode. So these are the few helps you have to do for me. Okay. You are able to see my screen?
Yes, ma'am.
Okay, nice. Am I audible properly?
Yeah, yes, ma'am.
Okay, fine.
Good.
Now let's go on to the session. So let's have a brief recap of lectures of week 1. So we'll go one by one lecture. So lecture 1. So what was lecture 1 about? Did anyone go through the lecture? Did anyone go through? If you have gone through, you can just give some points, whatever you remember from lecture 1. Or else anyway, the points are there in the screen also.
I have gone through all the lectures, madam.
Okay, so what is it the lecture 1 was about? What was discussed in lecture 1? Yeah, anyway, I'll start with. So the lecture 1 was the basic introduction to the course and to polymers also, right? And first of all, what are the advantages of polymers were discussed, right? Why it is, ubiquitous. You see polymers everywhere, right? Every day morning you get up, you will see some polymer, okay? Right? Some or the other polymer you come across every day, right? It is like spread like anything, correct? So why is it so? So these were all discussed. What are its advantages? Like the mechanical response and how ease of fabrication, the processing time. It can be processed. The cycle time to make one plastic object is 1 second or less. So this makes it very much is for fabrication, right? So that makes it uh, its usage expand like anything, right? And then the cost, right? The durability, for example, it does not corrode, correct? Polymers does not corrode, right? So this is one of the durability aspects. And what are the disadvantages of polymers? Like, the standard properties. Since the polymers are of macromolecular nature, they are giant molecules, right? So there will be variability in properties. So this is one of the disadvantage of a polymer. And then there's a physical aging and thermostability also, right? And, sustainability, performance. So these are some of the aspects of, so there are certain disadvantages in polymers as well. So what are the advanced applications? In fact, now you could see polymers even in electronics, right? In solar cells. So examples were shown from papers, right? In soft robotics, correct? And then a brief introduction to the course module was given. Like what are the things that are going to be covered? Like concepts, properties, concepts involved in polymers. What are the properties that are going to be studied? What are the uses aspects we are going to study and sustainability? So these aspects were all discussed in the lecture 1, correct? Are you all there?
Yes, madam.
Yeah. Now let's see what were all discussed in lecture 2. So lecture 2 was on what are polymers and its unique feature. So it is based on the concept structure. right? So first they started with a description of the modules, the concept, like why and how, and then properties, how much, any property is in case of a polymer, and what are the uses, where are its applications, and what about the sustainability aspects. So these modules were briefly, given an idea. Then, how do you describe polymers was discussed. Like polymers are macromolecules, they are giant molecules. And then the monomers were discussed, oligomers, the diversity of polymers around us. Even we are made up of polymers, right? Do you agree?
Madam, once again, please.
Yes, yes.
What is the question area?
No, no. Even we are made up of polymers, correct? Our body
Correct,
is made up
madam.
of polymers, correct?
Yes, yes, madam.
Yes. So can you name some polymers, in our body?
Yes, madam.
Huh, yeah, please answer.
Yes, madam.
No, what are the polymers do you find in our body? Any answers? All your proteins are polymers, right? And then plants are made up of polymers. So plants contains again proteins, polysaccharides. Again, your DNA is a polymer. It's a polymer of nucleic acid, right? Correct. And then the functionality of, you know, mm, polymer formation were discussed. One second. Admit, admit, admit. So welcome Bhavya and one more person joined. Sorry, Revati. I welcome you both for the session. So we just started discussing the brief recap of lectures. So before we continue, we'll have a brief introduction about Bhavya and Revati as well. Bhavya, are you there? Can you just unmute and say about yourself? Just few words. Like what are you doing and where are you from? Hello, Bhavya, Revati. Both of you, you are able to hear me?
I'm Revati.
Hello, Revati.
Ma'am, I'm Revati.
Hello.
Uh, I'm working as a faculty in BSc Crescent Institute of Science and Technology, ma'am.
Okay.
Chennai.
Oh, okay. Nice. Okay. Uh, so which course you're taking?
Polymer-Concepts.
Okay, you're teaching polymer concepts at your college.
My course, I was actually there in Polymer Engineering Department also.
Okay,
I
okay.
teach even Polymer Chemistry, Polymer Technology.
Nice, nice. Welcome to the course.
Thank you, ma'am.
Yeah. What about Bhavya?
Hi, ma'am. I'm Bhavya, and I am currently working in a startup, and I'm a junior research scientist there. Basically, I have started working on polymers, and I have joined this course so that I can get the base, like what polymers exactly are. So, yeah, this course is like really helpful for me for future.
Yeah, yes. Okay, good. Good. I welcome you. So make use of the course as much as possible. Okay. Now let's continue with the session. So there was description on functionality, right? Then there was a discussion on molecular architecture. So backbone, the side groups, end groups, degree of polymerization, branching. So these aspects were all discussed in lecture 2, right? Correct?
Yes.
Yeah. Okay. Uh, so what else were discussed in lecture 2? Some different structures were also discussed, right? Some comb-like structure, star-like polymer, correct?
Yes, ma'am.
Yeah. I request all of you to be as much interactive as possible. Okay. Next, in lecture 3, this was on again what are polymers and its unique feature, and this was again a concept based lecture. So here the process, structure, property, relations were all discussed. First of all, the basic polymeric materials like polymer, copolymer, blend, composite, porous polymers, polymer charge complex. So these terms were introduced, and then terminologies like melt processing, shaping, and then dispersion, machining, and all were introduced. Right? Next, what are the structures and properties? What are the states of interest in terms of polymers, like liquid-like properties and solid-like properties? Correct? Does anyone of you remember what are the liquid-like properties? Or, the terminologies used in liquid-like properties? So, polymers are dynamic, they can
Segmental
move.
motion.
Yeah, yeah, yeah. You were saying something?
Segmental motion,
Yes.
blast transition temperature.
Ma'am, macromolecular conformations.
Okay. So, diffusion, swelling. So, these are some of the liquid-like aspects where polymers tend to move. Right? Next, in the solid-like aspects, some terms like crystallinity, orientation, molecular arrangement, right? These were all discussed, and conduction of electrons, right? So these terms were all introduced in the solid-like property and associated properties. Next, there was a discussion on processing, structure, and property. So how processing affects the structure and vice versa. Similarly, there were examples given on how processing affects property and property affects processing, and how structure affects property, and similarly how property affects structure. So these concepts were all discussed in the lecture 3, right? Then lecture 4. So lecture 4 was on uses. So basically there was an introduction on biopolymers. The lecture started with classification of polymers based on the monomers, right? So based on the monomers, what are the classification of polymers? Can you say some examples based on the monomers, how polymers are classified? Someone? Please try to be interactive as much as possible. There is nothing right and wrong. If it is going to be wrong, it's going to be corrected.
Like
And if
polysaccharides, proteins, nucleoid, DNA, RNA.
okay, okay. So these are some of the biopolymers. Okay. So based on the monomers, how do you actually define this? Like you have, hydrocarbon polymers, fluorinated polymers, right?
Lignin, madam, lignin is also biopolymer, no?
Which
Lignin.
one? Lignin,
Lig,
yes.
yes.
Yes, yes, yes.
Madam, in the uploaded video, actually, this biopolymers chapter was abruptly cut in between. The full video was not available.
Oh, is it?
Yeah, I have even posted in the forum, and we did not get any reply for that.
Oh, okay, okay, okay. I didn't check the forum.
Yeah,
We
even
can just.
even before the xanthan gum, because the xanthan gum assignment came, only then we checked actually. Before that itself, it got stopped. Last 4 or 5 slides weren't covered in
Oh,
the
okay,
video.
okay, 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 okay. We'll just check and
I'll upload the new one, ma'am.
yeah, yeah, sure,
Update
sure.
one. Okay.
Yeah, I'll inform the uh, the team, and I'll ask them to make the correction. Okay.
Okay.
Yeah,
Because there
sure.
were many questions after that only. Nearly
Oh,
5 questions were there in the assignment after that.
okay, 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 okay. I think
Okay.
your xanthan gum portions were all not there.
Yeah.
Okay, okay.
No,
But
Xanthangum and next also. Next 2 slides, I think.
okay, okay. On the natural rubber.
Natural rubber. Yeah.
Okay, okay. I'll inform the respective team, and I'll just
Upload
ask
the
them to
new one.
sort the.
Okay.
Sure, sure, sure,
Thank you.
sure. Okay. So as we were discussing, so hydrocarbon polymers, fluorinated polymers. So these are, for example, hydrocarbon polymer. Can you name a polymer which is hydrocarbon polymer where monomers are just hydrocarbon?
Polyethylene, polypropylene.
Yes, yes, that's nice. Okay. So, and then what are the common families was discussed, right? Like polyesters, polyamides, polyolefins, polyacrylate. So these were all discussed. Then there was an introduction on natural polymers, correct? So where, the natural form of polymers, like your polysaccharides, and then your DNA, I mean nucleic acids, polynucleic acids were all given an introduction. And what are the related terms in terms of natural or biopolymers? Like there are bio-based polymers which are from natural sources, and then natural fibers, right? And then there was a discussion on polylactides and polyols, right? And then biocompatible polymers, biodegradable polymers, right? These were all discussed. And then type of biopolymers based on their type and based on their origin. So these were all discussed, right? So based on origin, what are the natural polymers, biopolymers? You have plant-based, animal-based, and microorganism-based, right? Based on type, you have your proteins, your polynucleotides, and polysaccharides. Correct? Are you all connected? I need
Yeah,
someone,
yeah.
yeah, just
Yes,
giving a
ma'am.
small
Yes.
response when I'm on the PPT mode, because I will not be able to see whether I'm connected or not when I go to the PPT mode. Okay. Next. So lecture 5 was on property molecular weight. Okay, the effect of molecular size, the length, branches, blocks. Right, blocks comes when you have these copolymers, right? And then cross links, the cross link density, right? And the segments between the cross links. So these aspects were discussed. And then mono and polydisperse polymers, right? Molecular weight distribution, the discrete and continuous molecular weight distribution, and different, molecular weight terminologies like number average molecular weight, weight average, viscosity average, and Z average were all discussed. And then polydispersity index and polydispersity coefficient was discussed in lecture 5. The lecture
Actually,
6,
in this lecture, ma'am, based on the molecular weight distribution curve, that the normal curve, these
uh-huh,
number average, weight average, viscosity average, and Z average was the identification of these were not really given properly in that lecture. That is, separately, the number average, weight average was discussed,
okay.
but along with that molecular weight distribution curve, how one is greater than the other or one is less than the other was not discussed actually properly.
In terms of the curve.
In terms of the normal curve, yeah,
Okay, okay,
molecular weight distribution curve.
okay, okay. But a question is asked in your assignment, right?
Yeah, yeah.
So just give it a try, search, and then get
Yeah,
back.
we have given actually. I thought it would be better if they explain also.
Yeah, that's fine. So
Okay.
just try it as an activity. Okay.
Okay.
Uh, I'll inform the professor also if that is
Mm.
added. I thought it is already added. I don't
Actually,
know.
it will be better. It's very important, for the
Okay. But I
newcomers to
think
know.
every lecture some references would be given, right?
Yeah.
So if you go through, see, it's not only about the PPT. You have to go through the references also. Okay. That is why, the reference is given so that you get some in-depth idea also. Okay. That is the
Okay.
ultimate purpose of references. Okay. So that you just go through the references as well. There should be
Okay.
some homework done also, right?
Okay. Okay. Without homework, we cannot do the assignment. We have done it, but I'm telling.
Yeah, yeah, yeah.
But that
That's why.
in the molecular weight distribution, that's a very important concept which has to be
Yes,
covered.
yes, yes. I
Okay.
think the reference would have been given. Okay, but I'll take this as a feedback to the professor and I'll ask him to add it in the lecture as well. Okay?
Okay, ma'am. Okay,
Yeah.
ma'am.
Okay, that's nice. So I'm happy that people have gone through the lectures and questions are asked on the lecture. That's good. And keep up this spirit. Please go through the lecture before the live interactive session so that these kinds of questions can be arised during the live interactive session and things can be sorted from both sides. Okay. Uh, okay. Now let's continue with the discussion of the brief recap of lectures. So lecture 6 was on concept of polymerization. Again, a molecular structure, how do you control the molecular structure and what is the goal of polymerization? So how do you control the tacticity and chirality? Okay, what are the architecture, like your sequence? For example, in case of proteins, your amino acid sequence, right, plays a vital role in what kind of protein it is and what kind of function it is going to do, branching, networking and other architectures, right? And then how do you quantitatively control your average molar mass, molecular weight distribution, average segment length, branch density, the length of branch, star branches, and all were discussed. And a brief introduction to step polymerization and polymerization of olefins were also discussed in this lecture. The final lecture of the week was on sustainability aspect. So in this lecture, what is the nature of bonding in polymers? Was discussed and the structure at multiple scales, right? Structure both in terms of length and time scales, right? Since polymer is a giant molecule, you have multiple scales, right? In case of polymers, right? From a single unit carbon-carbon bonding to segments to the entire macromolecule. So multiple scales and their arrangements play a very vital role in their properties. And also at the end their function as well, their processability as well. Okay. So and then the next on aspects of sustainability. So how can you convert back a macromolecule to a small molecule, right? How do you what are the possibilities of degradation of macromolecules, like scission of backbone, branches, cross links, right? And
Madam, how we have to go by utilizing the polymer for for sustainability?
that's what this is
Because
actually. Yeah.
because the degradation property of the polymer is very, the time of the degradation is very high. So how we
Yes.
have to go for the sustainable?
Yes, this is
How we
actually
can
the
see
big.
the sustainable polymer?
Yeah, this is actually a big question that is being, trying to being answered by different, researchers all over the world. Still, we have not come to a, complete answer. People are trying, like mixing a natural polymer or replacing a natural polymer. Like these aspects are also discussed in the course, right? Using a sustainable source, correct? And what are the possibilities of bringing in some kind of a degradation, and again degradation in the sense we cannot make the because for example you have different type of degradation also, like thermal photolysis, right, oxidation, hydrolysis. So all these aspects, for example heat, during the working period of the polymer also, the polymer may face some heat or face exposure to light. So the polymer should not degrade during its service life period, but and during the recycling period, but after its service life it should degrade properly so that it doesn't cause any problem to the environment. So this is a big question that is under research. So people think in different aspects, the possibility, like for example replacing or using a mixture of a natural polymer and a polymer from a non-renewable source, right? So these are some of the aspects that are being, put into the application so that we are starting to make polymers more sustainable. Okay, still it is, not completely sustainable, but works are being carried out in different perspectives.
Thank you, madam. Thank you.
Yeah. So that is where, people have started researching more on this, natural polymers, biopolymers and all. Right. So, there are still, some practical issues of, completely using a natural polymer also. So there are concepts like making a mix of the natural polymer and the synthetic polymer, and wherever possible, completely replace it by natural polymer. So these are the aspects, and how possibility of causing degradation of the synthetic polymers as well. So through different routes. So these are being carried out. There are certain things in the real life applications as well, where there are mix of natural and synthetic polymer combinations, and where your natural polymers are replaced by, sorry, synthetic polymers are replaced by natural polymers. So these are all brought into practical application as well, and there are a lot of things under research as well. Okay. So these aspects, like questions related to sustainability, the life cycle cost, a holistic degradation, and how can we really bring about polymers into the biogeochemical cycle. So these are still uh, trying being answered, and still unanswered as well. So these aspects are all brought into the course. So if you go through the course, if, in the future lectures also, different aspects of these will be dealt with, so that you will also get into idea. So you can also be a part of it as well. Okay. Okay. So I think we had a good recap of the lectures, right? Now can we get into the practice assignment session? Are you
Yes,
good?
madam.
Yeah. Okay. So now, first question. Lipase is a natural enzyme which cleaves carboxylic ester bonds. Among the options given, identify the polymer or polymers degraded by lipase. This is a GATE 2023 question. So bring to your notice, this practice assignment session will be mix of some theoretical questions, conceptual questions. It will also cover some mathematical problems, and also it will try to cover GATE questions. So those who are aspiring for GATE, this session on polymers will be helpful. Okay. So let's get on to the question again. Lipase is a natural enzyme. So this cleaves the carboxylic ester bond. Among the options given, identify the polymers degraded by lipase. So the options given are polypropylene, polycaprolactone, polyvinylidene fluoride, and polyethylene terephthalate.
I think, madam, we have to go
What?
for the answer A.
B. B. B.
Okay.
A.
So, okay.
A.
So
A,
why do
madam.
why do you say polypropylene? Why do you say polypropylene can be degraded by lipase enzyme? So when you're answering the question, I'll also ask why you have chosen that option. Okay, there's no response. Okay, someone said option B. Why is it so?
Because caprolactone contains NHCO bond, so this lipase can break that CO bond.
Okay, so any other answer?
Oh, it can be sorry. It is D, I think. Polyethylene terephthalate. Because ester group is in terephthalate.
Okay, okay. Anyone wants to try and give any
I
other
did
option?
not notice it. I thought it is PTFE. So,
Okay. So anyone else wants to try for any other option? Anyone else wants to give it a try? I have not confirmed where any of the correct answer. I've just listened to answers given uh, by you people. So if anyone wants to give it a try, you can give, or else I'll proceed with the answer. Nobody else wants to try. Shall I go ahead with the answer?
Yes, madam.
Okay, I'm going ahead with the answer. Answer B. Okay, Prajwal has said answer B. Why do you say it is answer B, Prajwal? Why do you say it is B, polycaprolactone? Okay, there's no response. So let me go ahead with the answer. It is actually polycaprolactone and polyethylene terephthalate. Why? Let's get into the structure of these polymers. So let's go into the question and then see the structures of these polymers. Okay, so lipase is a natural enzyme and it cleaves carboxylic ester bonds. So this carboxylic ester bonds are cleaved by lipase. So wherever you have the carboxylic ester bonds, those bonds can be cleaved by lipase. So from the given options, which are the compounds that have the carboxylic ester bonds? One, you can see the polycaprolactone. It is having this C double bond O. This extended chain, if you see, there will be one O connected here. So that will have this ester group. And similarly, your polyethylene terephthalate has this ester group. So these ester groups can be cleaved by, the lipase enzyme. Whereas if you look into the structure of polypropylene, it doesn't have any ester group, correct? It is just, it's a hydrocarbon chain with no other ester group. It has CH2, CH3. That is the structure of polypropylene. And similarly, in PVDF, we have CH2, CF2. Chain of CH2, CF2. Right? So, option B and D are the answers for the question 1. Hope you all understood. You all understood, right?
Yes, madam.
Yeah. So, so does this mean that polyethylene terephthalate is going to be a biodegradable polymer? This is a curiosity question.
It need not be because it is only degrading in the presence of the lipase. And lipase is not present everywhere in the
Okay,
soil also.
yeah, okay. This is one kind of answering this question. So still, lipase enzymes and there is also cleavage enzyme, if I'm not wrong. So these enzymes are, playing a role in, breaking these ester bonds and degrading the polyethylene terephthalate. But, still there are a lot of research going on, right? Okay. Now let's go on to the next question. Which one of the following is an example of biodegradable polymer? Polyethylene, polyamide 6,6, polypropylene, polylactic acid.
The
Polylactic
polylactic
acid.
acid.
I heard two people answering. One by one, can you answer?
Polylactic acid.
Okay. What was the answer by the other person?
Ma'am, same polylactic acid is the answer.
Okay. You are right. Next. Glass transition determining segmental mobility is an example of process determining property, property determining structure, structure determining property, or property determining process. This was discussed in the lecture. This is a direct question from the lecture.
Madam, answer B. Property determines structure. Actually,
Okay.
glass transition temperature gives the peaks value where the phase will be changes.
Okay. So Do all of you agree with that? Or anyone has any other answer in?
Actually, I think it will gives the crystallinity of the materials also. Polymer.
Actually, process determines property
Why do you say so?
because when we heat it, we'll have segmental motion at glass transition temperature.
Okay, there is a different answer from it's Revati, right? Okay, so I have got two different answers. So, any other answer from anybody else? Or shall I proceed with the answer?
Proceed the answers, madam.
Okay, so whoever answered option B, property determines structure, is the right answer. So, glass transition, it is a property, right, of the polymer. So, it determines the segmental mobility. For example, if the material is below its glass transition, it's going to be in completely glassy state and there's not going to be any segmental motions. Your segments are all frozen, right? Whereas if the material is going to be above its glass transition, you start getting your segmental mobility, right? Mobility gets arrested below the glass transition and you have better mobility above the glass transition, right? So segmental mobility is a structural aspect. So this structural aspect is determined by the property glass transition, right? Is it fine?
Yeah, yeah.
Yes, madam. Yes, madam.
Okay. This is actually directly taken from your lecture. Just go through the lecture again, you will get to know this point. Okay. Now, next question. The functionality of hexamethylene diamine for condensation reaction with adipic acid is?
Two.
Okay. Is there any other answer?
Madam, two.
2. Okay. Anybody else? Okay, no one else is answering. You are right. The answer is 2. So, your hexamethylene diamine has 2 amine group. Right? These are the functional groups which is going to react with the acid group of adipic acid. Again, adipic acid has 2 COH group. So these starts, reacting, forming a condensation product, right? Eliminating a water molecule, you will end up forming nylon 66. Okay? Okay. Next. Identify the protein from the below. Keratin, polypropylene, collagen, RNA, pectin.
Keratin.
Okay.
RNA also a protein, ma'am.
Okay. Any other answer? I've got two answers so far. One is keratin, one is RNA. Anybody else wants to try?
A and D both are correct, madam. Keratin and RNA.
Okay, I've got one more option that both A and D. Okay. Anybody else wants to try? I want someone who has not given any try so far to give a try also. Someone else? Or I'm proceeding with the answer. It's actually keratin and collagen. So keratin and collagen are proteins. Okay. Polypropylene is a synthetic polymer. Okay. And your RNA, ribonucleic acid, is a polynucleic acid. Okay. The monomer is a nucleic acid. And pectin is a polysaccharide. Okay. Fine. Now let's proceed with the next question. Identify the syntactic polymers among the following. So there are 5 structures given and you have to identify syntactic polymers. Which one are syntactic polymers?
color to case 9 color to case number
Madam
B and D.
ABD.
B, E.
Madam ABD.
A, B,
B and D.
D. Okay, one person is giving A, B, and D. Okay, and someone else also answered, right?
D and E.
D and E. Okay. So anybody else wants to give it a try? Let me proceed with the
Ma'am, A
answer.
and B only.
Huh?
A and B.
C and D.
No, A and B.
A and D or E and D?
A and B. Apple and ball. A for apple, B for ball. Yeah.
They are syntactic polymers, you're saying. Okay. We have got 3 different answers. Let's see what is the right answer. The right answer is D and E. So, what are the names of these polymers? Do you know the names of these polymers?
Polyvinyl chloride and polystyrene.
Okay, is there any other polymer in the set? Which is polystyrene among the options in the question?
D.
D is the polystyrene.
Okay, and what are the polymers there? You have said polystyrene and polyvinyl chloride. There is one more polymer in the question.
Polypropylene.
Yes. So if you actually look, A and D are actually polystyrene. Okay, it is just the different toxicity in each A and D. And B is your polypropylene. C and E is your polyvinyl chloride. Okay, so let's get on to the structure. So syntactic, it should be the alternate arrangement of this, the different group, right? So in this, uh, the general structure, if you see, it is CH2, CH, right? Only it varies by this, the additional, the fourth, attachment to the carbon, correct? So one has styrene in it, one has CH3 methyl group in it, and one has chlorine in it. So in case of the syntactic, if you see this, for example, in case of polystyrene, so isotactic means these styrene groups are all in one side. The benzene groups are all in one side. That is isotactic. Similarly, in case of your, uh, you know, uh, polypropylene, your CH3 groups are all in one side. This is isotactic. And similarly here, your all Cl group are in one side, right? Whereas in syntactic, there is an alternate arrangement. And in atactic, there is no sequence actually. So one time you will have your, for example, in case of polystyrene in one side, and the other time it will be somewhere else. The next is in the other side. Again, it comes in the, for example, left side. Next is both are continuously in the left side. So there is no kind of a sequence here. So this is atactic. So if you just look into the PVC structure, you can identify the tacticity if you just look into the dark and the shaded one. The shaded one is always on the other side, right? Which is not visible to us, right? So with that, you have to identify. For example, in syntactic PVC, you can see that Cl in one, the first atom, it is in first carbon, it is in the one side, whereas in the second carbon, it is in the back side. Similarly, third one is in the front side, fourth one is in the back side. So there is an alternate arrangement. Right? You are able to follow the structure. You just have to note this dark shaded portion and the lines. So that the lines one are in the back side, right? Or in the other side. You all got it? Are you all there? You're all fine?
Yes, madam.
You're able to understand, right?
Yes, madam.
Okay. Okay. Now let's proceed with the next question. Crystalline arrangement in polyethylene dioxythiophene P dot and distribution of P dot and PSS domains affecting the electrical conductivity of P dot PSS thin films is an example of property determining structure.
Question is not visible.
My screen is not visible, is it? Now is it visible?
Yes,
No,
ma'am.
no.
Uh, Others, you're all able to see?
Madam, visible.
Okay,
Yeah,
I
it's
think
visible, ma'am.
Revati, it's not visible for you, is it?
Yeah, it was not visible.
Now is it visible?
Yes,
No.
madam. It is clear, madam.
Okay, it's not visible for me. I'll just check out what's
Just maybe you can just log out and log in.
okay.
Just give it a try.
Madam, there is a two property
Now it's visible.
Now it's visible. Good. Okay.
in property determining structure. Second, structure determining property. A and
Okay.
C.
A and C, you say.
Yes,
Okay.
madam.
What about
Madam,
others?
actually we are getting the thin film, which uh, electrical conductivity showing. So I think there is a property determining structure. There is the structure is fibrous structure or crystalline structure through which electrical conducting occurs. C, structure determining property also. What type of the structure? If it is a crystalline structures, then we can not linear electrical conductivity. So A and C both.
Okay. So what about others? Do you agree with him or you have any other? So I'll read the question again. Crystalline arrangement of P dot and distribution of P dot and PSS domains affect the electrical conductivity of P dot PSS films. Okay. This is an example of what kind of relationship? Is it property which is determining the structure, or it is the process which is determining the property, or is it the structure which is determining the property, or is it the property that is determining the process?
Structure determining the property.
Okay. So anybody else wants to give it a try? Okay, I'll proceed with the answer. So it is actually the structure that is determining the property, because the question is very defined, right? So it says that the crystalline arrangement and the distribution of P dot and PSS domains affect the electrical conductivity. That means the crystallinity of the P dot and how P dot and PSS are distributed in the film. Okay, it is affecting the electrical conductivity, which is nothing but the property of the system. That means the structure of the system is determining the property of the system. The structure, for example, the crystallinity is affecting the electrical conductivity. That means it's a structure that is determining the property. Okay, I think someone said A and C. You got it? It is actually the structure that is determining the property. You're able to understand?
Yes, ma'am.
Okay, fine. Now, next question. During rubber processing, dash occurs and affects the rheological property changes. What happens during rubber processing that affects the rheological property? Rheological property is nothing but a flow behavior.
Cross-linking,
Okay, anybody else wants to give a try?
vulcanization,
Okay, now let's proceed with the answer. You're right, it's a cross-linking reaction. Vulcanization is nothing but your cross-linking reaction where your sulfur starts cross-linking the rubber. Okay, that process is called vulcanization of rubber. Okay, so once it starts getting cross-linking, the flow behavior of the rubber changes. Okay,
Madam, how we have to define the rheological property?
I didn't understand your question. Define the rheological property in the sense.
Yes, madam. What no, what is the rheological property of the material, the bulk?
See, rheological property is it's basically your flow. We are trying to understand the flow behavior. Okay, so for example, in
Okay.
this case, so when you start cross-linking the system, rubber, initially, which is for example a melt, which is flowable. Okay, so once it starts getting set, okay, through cross-linking or through some solidification mechanism, something, what happens is the flow starts slowly reducing. So this is what is the rheological change, right? The flow behavior pattern is getting changed.
Okay, okay, madam. Thank you, madam.
Yeah, this is one kind of an example of the flow behavior change. Okay, yeah. Now next question. So this is a GATE 2024 question. A monodisperse polymer sample of molecular weight 10,000 gram per mole is mixed with another monodisperse sample of the same polymer of molecular weight 50,000 gram per mole. The total mass of the mixture is 1000 gram and the total number of moles of the polymer in the mixture is 0.04 mole. The weight average molecular weight of the polymer mixture is dash gram per mole. Okay, this is the question that is asked in GATE 2024. In addition to this, there are two more questions that is being asked. First of all, we have to solve this question, and also in addition to finding out the weight average molecular weight, we have to find out what is the number average molecular weight and polydispersity index of the system. Okay, so can
Madam,
any, yeah,
we have to require the formula here, no, madam?
yes, you have to use the formula.
Molecular weight and number average molecular weight both. Then we have go to for the polydispersity intermixture.
Yes. So you have to know the formula. Now, someone has to say how to start this question with. So as one of you said, we have what is being asked is what is the weight average molecular weight, what is the number average molecular weight, and what is the polydispersity index. So what are the parameters that are given and how to go about this question? How to start with What is given in the question? At least someone can read and say, right, what are the things given in the question? So what is given? There are two polymers that are being mixed, right? One
First,
polymer is yeah.
first we have to go for the molecular weight, MW bar. We have to find out with the given data as the molecular weight of the sample A and the dispersion, the second molecular weight of the second polymer.
Okay. Okay. So we have been given molecular weights of two polymers. I mean, the same polymer, but of different molecular weights that are being mixed, right? So in one, the polymer is having a molecular weight of 10,000, and in the other, the polymer is having uh, weight of
50,000.
50,000.
50,000.
50,000. Yeah. And then the total mass of the mixture is given, correct? So we have monodisperse polymer 1 of molecular weight 10,000, monodisperse polymer 2 of molecular weight 50,000. And the total mass of the mixture is 1000 grams, and total number of moles of the polymer, right, after mixing is 0.04 mole, right? Now we have to find out weight average, number average, molecular weights, and polydispersity index. So what is the formula for weight average molecular weight? Okay, let me proceed with. So weight average molecular weight is given by summation NIMI square by summation NIMI, right? So where Ni refers to the number of moles of polymer 1 and number of moles of polymer 2. When if it is N1, it is number of moles of polymer 1. If it is N2, number of moles of polymer 2. Similarly, for M1, it is molecular weight of polymer 1, and M2 means molecular weight of polymer 2. Okay. Can you please mute yourself if you're not answering to avoid disturbances? Yeah.
Madam, here we have to take Ni is 1
Why should you take Ni is 1?
because the first sample is not given the number of molecules.
Only the first sample is not given the number of molecules?
Okay, okay. Sorry, madam.
It is actually both the polymers, the individual number of moles are not given. Only the total number of moles in the final mixture is given.
Madam.
Okay?
Yes, yes, madam.
Yeah.
Yes.
So, first one, we have been given the total weight. So, summation NIMI is, so N1, M1 is weight of polymer 1. N2, M2 is weight of polymer 2. So, summation of weight of polymer 1 and summation of weight of polymer, summation of weight of polymer 1 and 2 is the total weight, right? So they have given what is summation of NIMI. So that is WT, that is 1000 they have given already. Similarly, so N1, M1 plus N2, M2 is 1000, correct? They have also given total number of moles in the final mixture. NT they have given. So that is N1 plus N2 they have given, that is 0.04. So we have two equations and two unknowns, right? We can solve these two equations, correct? So we just have to replace N2 in the equation 1 in terms of the equation 2, right? That is what I have done here. So N1 into M1 is, they have given 10,000, and in place of N2 I have just replaced it with the equation 2, which is nothing but 0.04 minus N1, because total number of moles we know. So these are the two unknowns. So the other N2 will be the total minus N1. That is what I have substituted. And then we have molecular weight of polymer 2, which is 50,000. is equal to 1000. Right? Now, can any one of you find out what is N1 from this solving this equation? The simple mathematics. Solve this equation and then tell me what is N1.
First, it means we have to find out N1 and N2. Then we go for the formula MW bar.
Yes. But now find what is N1. The equation is here and all the other values are here. Only N1 is the unknown. Just do the mathematics and tell me what is N1. Any one of you can try and tell what is the value of N1. If you have a calculator, you can just do it. Or if you have your mobile beside you, you can do it. You can open the calculator in your mobile and just do it. And also a paper and pen. I request all of you to have your notebook or something with you and also a calculator because we'll be solving some numericals also in the following sessions as well. So did someone try calculating it? Is anyone giving a try to calculate it?
Yes, try.
Okay, good. So I'll just wait for a few more minutes for you to calculate and say what is N1. So what is N1?
Zero point 0.0125, ma'am.
0 point? Can you repeat please? Someone said some answer, but I'm okay. 0.0125. Is anyone else also getting the same answer? Someone else was trying, right? Revati was trying, right? Revati, are you also getting the same answer or you are getting a different answer?
Wait. I don't have the calculator. I'm just trying now.
Okay. If you have your mobile beside, you can do it. Or if you are, if you join the meeting through laptop, then you will have a calculator in your laptop as well.
Madam, show the screen. Thank you, madam.
Yeah.
Madam,
Hmm.
it's 0.22 N1.
0.22. Okay. One
I
person has said 0.0125. One person has said 0.22.
again I am checking, madam. Sorry. Minus. Sorry. Minus 40,000.
The simple mathematics. Shall I proceed?
Yes, ma'am.
What about others? Shall I proceed?
0.025.
Okay. Okay. So shall I go ahead? I heard three answers: 0.0125, 0.025, and 0.22. Let's see what is the right answer. It's actually N1 is 0.025. Okay. 0.025 is the right answer. And N2 is nothing but 0.04 minus N1, which is 0.015. So now you have N1, N2, M1, M2, everything. Right? Now we can find what is the weight average molecular weight. Correct? So what is the weight average molecular weight? You have to just incorporate in the formula.
0.025.
So you just have to incorporate in the formula. Someone wants to give it a try. What is the weight average molecular weight? You have N1 which is 0.025, M1 which is 10,000, N2 which is 0.015, and M2 which is 50,000. Calculate the weight average molecular weight and say what is the answer. Is someone doing the calculation? Is any of you trying the calculation?
Madam, I
10
am
to the
trying.
power of 9.
Huh?
10 to the power of 9.
10 to the power of 9. Okay. I've got one answer.
N2 कितना N2 0.015.
1 more minute.
Madam,
40,000,
37.5.
40,000,
Huh?
40,000.
One person said 40,000 and one more person said some other answer. No, what is it?
37.5 into 10 the power 3.
Okay. Okay. Now let's see the answer. So it is n1 into m1 square, which is 0.025 into 10,000 square, plus n2 into m2 square, which is 0.015 into 50,000, divided by summation NIMI. We have the
Yes, madam.
value of summation NIMI, which is 1000. So substituting that, we'll get the molecular weight as 40,000 gram per mole. Okay. Now next part of the question is the number average molecular weight. Does anyone remember what is the formula for number average molecular weight?
Sigma NIMI by sigma NI.
Okay. So calculate and say.
Madam, please give the formula here.
It is sigma NIMI by sigma NI. So what is the value of sigma NIMI? Do you really need to calculate sigma NIMI?
No, ma'am, it's 1,000.
Yes, perfect. What about sigma NI?
25,000.
It's 0.04.
Yeah, so sigma NI is 0.04. So 25,000 is the right answer. So it's very straightforward. So the number average molecular weight is summation NIMI by summation NI. So summation NIMI is nothing but your total weight, which is given, that is 1000. And summation Ni is nothing but total number of moles, which is also given, which is 0.04. So dividing 1000 by 0.04, you get 25,000 gram per mole. Okay. Now next part of the question is polydispersity index.
1.6.
Okay. What is the formula?
MW by MN.
Yes, you are right. So polydispersity index is weight average molecular weight by number average molecular weight. So you have both the values, 40,000 by 25,000, which gives you 1.6. Perfect. Okay. Hope others also understood. It's very simple question. It is simple mathematics. That's it. You have to remember the formula and mathematics. That's it. Okay. Now let's go on to the next question. Identify the polymers from plant source from the below. Xanthan gum, rubber, kesin, gelatin, pectin. So which are the polymers or polymer from plant source from the given options?
Rubber, ma'am.
B
Huh?
and E.
Huh?
Rubber.
B and E.
B and E. One person is saying B and E. Someone else said some other answer. What is it? What was the other answer someone else told? I was able to hear a male voice.
Madam,
Can you
A
say
and B.
A and B? Okay, so one person told rubber and pectin. One person told xanthan gum and rubber. So, so shall I proceed with the right answer? The answer is B and D. That is rubber and pectin. Rubber is again from a plant source, from a tree, and pectin is again from plant source. Okay. Xanthan gum, it is from a bacterium. Okay, it's from a Xanthomonas species bacterium.
Yes, 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 madam. That is the assignment in the question.
And gelatin and casein are from animal sources. Casein is a protein which is present in milk, right? And again, gelatin is again a protein from animal source. Okay. Now let's proceed to the next question. Polyethylene polyethylene varieties have densities in the following order: HDPE, LLDPE, followed by LDPE and BLDPE. That is high density polyethylene, linear low density polyethylene, low density polyethylene, and very low density polyethylene. The differences in densities are due to the ability of the chain segments to pack themselves next to each other. From the figure, choose the correct representation of branching for the variety of polyethylene. So, structures are given and the names are given. You have to match which one matches with what. What is the structure of high density polyethylene? What is
2.
the structure? Okay, so you're saying A is 2,
A is 1.
A is 1 person is saying. Okay,
C is 2.
C is 2. Okay,
B is 3 and C is 1.
B is 3 and C
A is
is
1.
1.
Madam, A is 1. Again, I am repeating. A is 1.
Okay,
B is 2.
okay,
C is 3. No, sorry. A is 1. B is linear, linear low density polyethylene. B is 2. C, no, there is some confusion. A is 1. D is 2. A is 1. D is 2. And C is 4. B is 3. Again, I am repeating. A is 1. B is B is 2. C no B is sorry, B is confusion हो जाता है. A is 1, D is 2, A is 1, B is 3, C is 4, and D is 2.
okay. Now let's see what is the actual answer. Okay, so actually 1 is low density polyethylene, 2 is high density polyethylene HDPE, 3 is linear low density polyethylene, and 4 is very low density polyethylene. Okay, why is this so? Because this HDPE for the case, it is called as high density polyethylene. If you look into the structure,
Branching is difficult in this process.
the branching is very less in case of high density polyethylene. That means more number of chains can be packed together. That makes it to have a higher density. Correct? Whereas in the other cases, the branching increases, and that is why, in case of LDPE, you have a higher branching, so it is having a lower density. Okay? Hope you are all able to understand. In case of linear low density, there will be a longer linear chains followed by a branching. Okay? That is why you could see that the branchings are at a longer distance compared to a low density polyethylene. And the very low density polyethylene will have a lot of branches. Okay? Hope you all got it. Now let's go to the next question. Which of the following statement is incorrect? Nylon 6,6 is produced by condensation polymerization. Phenol formaldehyde resin is a thermosetting polymer. High density polyethylene is produced by condensation polymerization. And polyethylene terephthalate is a polyester. This is
C.
again C, you're saying high density polyethylene is produced by condensation polymerization is a incorrect statement among the given statements. So do you all agree with that? Do all of you agree with what Revati told, or do you have any other option? Anybody else wants to give it a try? Someone can please respond, please.
Yes, ma'am. I also think she is wrong. C option C is wrong because
Uh,
SDP produced by additional polymerization. I
uh,
guess so.
okay, okay, okay. So two people have given the option as C. Anybody else wants to give it a try, or shall I proceed with what is the right answer? I think there is no other response. I'll proceed with the right answer. So both of you are right. So high density polyethylene is produced by condensation polymerization is the uh, wrong answer. So HDP is formed by, as one of you said, it's formed by either chain or addition polymerization, where you have the active center free radical ion formation. Okay, this kind of a polymerization happens in case of a HDP, high density polyethylene. Okay, the other statements are correct. So nylon is produced by condensation polymerization, condensation of adipic acid and hexamethylene diamine, where a molecule of uh, two molecules of water gets out. And the polyethylene terephthalate is a polyester. You have the ester group. And similarly, phenol formaldehyde is a thermosetting polymer. It forms a 3D network. You could see the 3D network formed in phenol formaldehyde that makes it thermosetting polymer. Okay, that's it with the questions. So, any other doubts? Any other doubts? Any other doubts? I think initially Rajiv or someone asked on some polymer composite.
Yes, madam.
Yeah, you can ask your question. First of
No,
all, there's
madam. I
okay,
have prepared one nano composite material based on the conducting polymer. We
okay.
want. I want to characterize them. There, I have no facility for the lab for the characterizations. Some characterization like SAM, TAM, and FTIR,
You
XRD.
you want to know what are the characterization should be done, or
No,
you want
no.
to know
I
where?
want to. I want to send some sample to you if you give me the permissions, and
Uh,
if the facility is there in your labs, so that we have to characterize them. We have to go for that the writing the papers, some other things.
okay, okay, okay. So you want to know whether facilities are there. See, there are a lot of facilities like you can do SEM, TIM even, and then FTIR characterization in IIT, IIT Madras. Okay, so there is
I
you
want I want to ask from your side, कि if I send the samples to you, can we go for that process?
you cannot directly send it to me. You have to check in the IIT Madras website. So there is a common facility called
The
sophisticated
cost
analysis.
is very high, madam.
Okay, okay, okay.
We are
Oh,
the
okay.
self-finance institutes. We are not getting the finance
Okay,
from
okay, okay.
somewhere.
You are
So
seeing.
if I am a student of this course, can we get the facility to
Oh, okay, okay,
characterize?
okay. So, no, that way it is not possible. Personally, in our lab, we don't have these facilities of characterizing, like doing like SEM and all in our lab.
Not
Okay.
personally, madam. You are the
We
guide in that matter for me.
no, no, even when we have to do our experiments, we have to pay.
Yes, madam. So
Okay,
for
so
your
it's
the payment will be done a low your for your side.
but we are not supposed to do these kind of. It should be formally sent. We cannot just give some get some sample from someone on our personal basis and all. Okay, it
Yes,
has to be
madam.
through the system. Okay.
Yes, madam.
Uh,
So if
uh,
you can help me for that, I am asking.
okay, okay. No, personally, we can't get because we also go through certain procedures for our samples to be tested. So I cannot take a random sample and just go for the testing. So if you want to avail the facilities, you can go through the IIT Madras website and just check for the facilities available. Okay.
Okay, madam. Thank you.
Any other questions? Any other doubts? Any other doubts? Were you all able to
No,
follow the
madam.
session? Okay, you
Yeah,
don't have
yes,
any
madam.
doubt. Okay, you were able to follow the session. So you're able to understand whatever I was trying to explain, right? Any difficulty you found?
No, madam. No.
Thank you, ma'am. Nothing.
Thank
Okay,
No, madam.
okay.
Yeah, thank you
So
so
if
much.
you
Yeah.
have any feedback, please let us know. Okay. See, for example, if I am, explaining too fast or too slow, please let me know that also. Or if I have to bring some changes in the slides, more information
It
or
is
less.
good, madam. It is good, madam.
Okay. Okay, but keep this in mind, and also, if you have any questions, just post it in the forum or you ask in the live sessions as well. Okay, we'll try to answer all those questions. Okay, so make use of the session. Try to answer your assignments well. Okay.
Kindly update that biomolecules, ma'am.
Huh, yeah, yeah,
Biopolymers.
yeah, yeah. I'll just check with the respective team and update the same. I'll inform the team and you know uh, change the video. Okay. Uh, Anything else? If nothing else, we can officially close the session.
Okay, yeah, yes, ma'am.
Okay. So hoping to see you all in the forthcoming sessions as well.
Thank you, madam. Thank you.
Okay. Thank
Thank
you.
you.
Yeah, sure, ma'am.
Thank you.
Yeah,
Bye.
Yeah. Happy
Thank you.
weekend. Thank you all.
Thank you.
Thank
you
Bye.
too,
you.
ma'am. Yeah.